Hello everybody, hello and welcome to this day 3 of the basic ROS Learning week. So we are already on Wednesday, and today we are going to start to learn ROS. We are going to start with the basic concepts. I was having a look here at the chat before starting, and I was seeing people from many places as the whole week. So I can read here, hello from Greece, hello from Brazil, from Paris, from Seattle. So excellent. First of all, let me know if the sound is right, if sound and image are right. You can see me, you can hear me. Yes? So that I can continue normally with the live class. Let me know, please, if everything is correct and it's fine. And meanwhile, I read your comments. I'm going to go back to my PDF screen here, where I have the schedule for the week. So let me wait a couple of seconds until I get confirmation here. Hello from Poland, San Diego. Be careful with COVID, Alberto. Yeah, I am being super careful, COVID. Don't worry. Thank you very much. Sound is okay. Hello from Ecuador. Sounds good. Hello from Colombia. Yes. Okay, so everything is perfect. So let's go. Let's start. So yeah, as I've said at the beginning, we are on Wednesday, so we are on day 3 of this basic ROS Learning week. So on Monday we did some Linux for robotics. Yesterday we were working with Python for robotics. And I don't know if some of you have done this evaluation test, which is optional, and if so, if you have passed it, not, did you find any problems in order to solve this test, this exam? Let me know also. But today, no Linux, no Python. Today we are going to start learning ROS basic concepts, and also today we are going to do a switch of platform. So we are going to leave the Robotic Night Academy, we are going to start working in the ROS Development Studio. Yep. So first of all, let me come here to the ROS Development Studio. So the first thing I want you to do is to come here to this web page. You can enter by rosds.online. You can, if you are in the academy, you can come here as well by in this menu, but I want you to come here to the ROS Development Studio. Yeah, this is not academy, you don't have any course here. Here you have a list of projects, which we are going to see right now what they are. But I want you to be all here. And then here, as you can see, I have a list of many ROS projects, which basically, if you don't know, are ROS projects. So inside each of these ROS projects, I have a full ROS project with packages, with Gazebo simulations, also with Jupyter Notebook, so that I can have some explanations there and some theory. Yeah. And the most interesting thing about this project is that I can share them with anybody in any place of the world with just a URL link, and then automatically you will have the same project, exactly the same project with the same setup as I'm having here. Yeah. So that's what we are going to do right now. So I'm going to come here and 1 second. All right, so first of all, let me know. Everybody is here in the ROS Development Studio. Yep, loading. Is there a deadline for writing the exam? You say here, Engineering Nation. No, there is no deadline. So, well, you have you are supposed, I mean, you can do you can access the exam anytime. It's totally free, so don't worry. You can do it today, tomorrow, next week if you want. Yeah, so it's up to you. Don't worry about that. Alright, completed the test whilst cooking dinner but not had results back yet. Has anyone else had results? Okay, Richard Voice is Alex Chart is saying you can share projects forked from private projects. Yeah, that's what I'm saying right now. But don't worry, I'm going to fix this right now. So don't worry about that. I don't have all the projects you have. Yeah, that's normal. This is all projects that I have created or that I have taken from somebody that has shared to me. So basically, you will have this empty. If you have just entered here and have not created any ROSes, you will have this empty. Yes. If you have been working already with the ROS Development Studio, probably you will have already some here, maybe from live classes, I don't know. But crash it to CPU, page is dead, thank you, not loading. The page isn't working. Okay, let me check this. Give me just 1 second here. Yeah, it looks like there's some kind of problem here. Okay, 1 second. I'm going to try to solve this ASAP. Let me switch to my camera so that you can see here that I'm here. I haven't left. I'm just trying to solve this issue that it appears but why you are saying that you cannot access the web page. So let me see what's going on here. Okay, let me see here. Not loading. Yeah, mine just loaded in. It took a while. It worked for me now, but I had to refresh. Okay, now it is working. Now it is working. Okay. So it seems that it's. Let me know if it's working, please. It looks like it's working now. Yes. Thanks. Okay, so I'm going to right now. Just give me a second. I'm going to share the link here. So. Give me just 1 second. I'm going to grab here my computer. So these are problems from the live, you know. So I'm going to solve this right now, and I'm going to share with you the link. Let me check here. Loaded, it's working. Okay, now it's working. Yes, now it worked. Okay, excellent. So it seems that it's been solved, the issue. Great. So now what I'm going to do is that I'm going to share with you the link from my project. I'm going to show it to you right now, how to do it. So don't worry. Yeah, Marta Gandolo says, I only have one project, but it does not look like yours. Yeah, don't worry, Marta. It's normal that you don't have as many projects as I have. I have many here because I have been working for many time in ROS in the ROS Development Studio. So I have many projects here, many projects. So don't worry, it's totally normal that you don't have that. But now I'm going to share my project with you. Here I will put the link here in the chat, and you are going to be able to get it in your workspace, yeah? So don't worry. Ethic Harrell says here, Mac from the 90s, I suppose. Well, it's not that old, actually. It's it might have, I don't know, 5 years or so, and so far so good, so I can't complain. Let me see here. Okay, so All right, so let me come here 1 second. Link. I'm just sorting everything so that I can share with you the link, yeah? So don't worry. Let me see here. All right. Yeah, give me just a couple of minutes. I'm going to share the link with you right now. Okay. Still, it appears that there's some kind of problem here. Let's see. Okay, so I am communicating here with my colleagues, and they are having a look here at the possible problems that there are in the web page. So meanwhile, I get the link and I share it with you. They are going to try to solve anything, and be patient because we are many people trying to log in at the same time, so there might be some problems here. And it might be a little bit slower than usual. So be patient with that. Okay. Okay. Let's see. Let me check here 1 second. Okay. Okay, let me, I think I'm almost there. I almost have it. So let me check this real quick. Okay, yeah, I think I have it. So I'm going to come here. Let me grab the link. There we go. Now I need to come to my ROSDS webpage. Okay, let me get here a quick drink. All right, so okay, so I think I have it. Let me see. Yeah, so these are the, as I've said, these are the problems of the live, unfortunately. So okay, yeah, so not yet. Just 1 second, please, guys. Okay. All right, never mind. I'm going to, okay, yeah, here I have it. So get this link here. Okay, so pay attention now, because I'm going to share the link here. Okay, there it is. Yeah, so now all of you here, you will see in the chat that I have just shared the link. So now if you click on this link and you have ROS, you are logging into the ROS Development Studio, you are going to see this link. You are going to get the project, this project specifically. Let me show you. I'm going to switch to my computer screen again. So you are going to get this project. Let me refresh this. Let me close my computer. Got it, worked, link. All right. Yeah, so all of you, once you click on the link, you should get here this project. Yeah, Basic ROS Learning Week Day 3. Yeah. So all of you should have this. Then once you have this, you can click on the open button and open project. Yep. Then I'm going to do this right now here. And meanwhile this loads, I am going to explain you a couple of things. So you will get this screen. Meanwhile, all the project is loading, all the packages, notebooks, etc. is loading. So this might take a couple of minutes maximum. But meanwhile, let me switch back to my pretty face. So meanwhile, I want to talk with you and explain you a couple of things. First of all, let me have a look at the chat, how this is going. Got it. Working now fine. Loading. 500 internal server error, says Arman. Try to refresh, Arman, and see if it works. I have the project, work it, yes, done, loading, okay. Okay, for the ones, loaded, yes, preparing project files, okay, great. So it seems like it's working. Maybe I have seen one message from Arman who says that he got an error, but just try to reload the page, and maybe it will work. Okay, so if you get an internal server error or something like that, try to refresh and probably it will work. Yeah. Then meanwhile, things I want to talk about. So first of all, I want to tell you that in the previous days, in Monday and Tuesday, many of you here in the chat and also in our forum were requesting us to create some kind of place where you can talk between us and also with us, with the Construct team, in order to create a sort of community, study group. I don't know how to say it, yeah. But we told you that we were thinking about it, and finally we have come out with a solution that we think it's the best one at this moment. And basically what we have done is to create a Discord server. Yeah, then any of you can join the Discord server and you are going to be able to talk with us and talk between us, etc. I'm going to show you right now this. Yeah, I'm going to, yeah, so mine here, as you can see, I don't know if, no, yeah, so mine has already loaded. It should take like I don't know, 2 minutes maybe, between 1 and 2 minutes it could take to load everything. And at the end you should have something like this. Yeah, mine has already loaded. So let's wait. Let me have a look at the chat and see how it is going for you guys, if it has loaded for you. Yeah, just select the basic option and continue. In fact, you shouldn't be able, you're not going to be able to select any other. Yeah, so you have to select the basic option and open project. And as I've said, it's going to take loaded, excited, loading. Okay, so it looks like people is starting to get the project loaded. Excellent. Loaded, loading, still loading, no yet, loading. Okay, that's fine. I'm going to wait a few minutes. I want to show you the Discord, our Discord server, but when everybody has this loaded. So first of all, I want to give a shout out, yeah, to one of our assistants here from the live classes of Monday and Tuesday. Let me find here the thing I want to show with you. It's this. So I want to give a shout out to Abdel Rahim here, because he shared I think it was yesterday with us through the Instagram stories. He shared here this very super nice picture with the setup here in one side. I don't know if they are two different screens or same screen divided into parts, but in any case, he has here in one screen, he has the live with what I am doing and explaining, and in the other screen he has the academy opened while working and testing everything and doing everything with me. Yeah, so it's super nice. This is the way we want you to work, to have to listen to the live class, but also be working at the same time. Yeah, so we loved this picture, Abdel Rahim, and thank you very much for sharing it. So I wanted to give a big shout out to you. And now, yeah, let me go back to the channel here and see. Let's see how this is going out. Still low. I'm reading the comments here. I can see some people who can't load. The ones that can load, what message are you getting? Are you getting any error? Error 503? That is really, really strange. Ready, internal server error, loaded, can load. So it's strange because it seems like for some people it's working, for others don't, which is pretty strange. So at the end, let me remember that you should have something like this, yeah? And let me remember as well that yeah, I got there. Let me see if I can have it again. Yeah, so I got here also an internal server error. It looks like sometimes it's getting internal server error, but and it's taking a long time to load. This is probably because of the load balancing. But if you refresh, it should work. Yeah, you can see here I am getting the internal server error, but I am going to refresh, and now it's going to work properly. Yeah, I don't know very well why this is happening. I cannot check it now because I am here doing the live class. So later we will check about this. I have already told my colleagues to check this because it's really strange. But if you, in case you get an error like this, just refresh and it should work. And then remember, the project you have to open is this one, Basic ROS Learning Week Day 3. Yes? You click here on the open button and open project. Yes? And then at the end, you are going to end up with a setup like this one. Yeah, so this is the process you have to follow. In any step, if you have an error in any step, try to refresh the browser and see if that fixes the issue. Yeah. So yeah, let me go back here to the comments and see how it is going. Okay, I am checking the comments, guys. So, okay, yeah, just reload the page in case of error. I can I can get the ROS Development Studio to load. If we can access it later, then I can just watch in later. Thanks for hosting these classes. Okay, M Kraken. Yeah, anyways, try to reload, because it should work by reloading. In any case, if not, you can watch the live class anyways, and then you can try it later, because this video is going to be uploaded as a regular video on YouTube. And also you are going to still have the ROSject link. We are going to put the ROSject link here in the video description as well when this finishes. I can see a message here from Isik. I want to buy your glass of coffee. This one, it's super nice. Also, you can, I think you can, you have the links in the video. This one, right? Yeah. So I think you have the links as well in the video description. So it's super nice, and coffee tastes better in this cup, let me say. All right, so let me have a last look to the comments, and I'm going to start with this. Here in my ROSject, let me close this. Here I have my ROSject. Excellent. And let me have a last look at the comment section here. Inside, let's start. Okay. Everything worked as supposed, ready to start. I can found basic ROS Learning week. Okay, let me share one last time. I'm going to share one last time the link, and I'm going to start. Yes. I'm going to put one more time the ROSject link here. And I will start. So, all right. Okay, here I have shared again in the channel the link. So for the ones that came later, here you have again the link. Click on the link, and you are going to get this ROSject, the ROS Learning Week Day 3 ROSject. Okay, yeah. So I'm going to keep going here. Meanwhile, the last people is loading their ROSject. So. Yeah, before starting, let me tell you about this, because it's also important. So I'm going to share with you here our link. Where do I have it? I have it here. Just 1 second. Okay. So here I have shared with you our Discord channel. Yeah. So if you click on this, let me do it here. You are going to be able to join our Discord. Let me change here to the PC screen real quick. Okay. So let me show you how it works here. So here, as you can see, you can join, you can add an alias here, and you're going to be able to join and enter our Discord page. Yeah, I'm going to do this later. And here we have basically, yeah, I can see that many people is already entering, so that's great. Excellent. Here we are starting to be everybody. And here you can see basically two groups. We have the ROS study group, which basically is for you to discuss about about ROS courses, about courses in our Robotics Ignite Academy or live classes, I don't know, so that you are not studying alone and you can share your studying experience with others. And then we have another group here, which is ROS Developers Group, which is for discussing about your ROS projects, if you are working in any specific ROS project, so you can discuss about it here. Yep. I can see many people it's entering here. That's great. So yeah, feel free here to start talking between you. We also all of the construct team, we are going to be here checking it and talking with you. So yeah, that's great. So I'm going to skip now Discord, and I'm going to start with the live class. Yeah. So let me check that everything is correct and everybody's on the same page. Okay, I have seen here one comment which is interesting. I tried on Opera web browser. Now I swapped to Chrome, worked better. Yeah, please, if you try to work in Chrome, yeah. If not Chrome, Firefox. But the better web browser for supporting our sites is Chrome. So that's another option. Yeah. If you are trying to load it with a different web browser, try to use Chrome or Firefox. Yeah. Alright, so let's go. Let's start with this. So I have here my project. First of all, this is the ROS Development Studio. You can see many differences from the Robotics Night Academy. If you were with us yesterday and on Monday as well, you can see that the environment is quite different. It's quite different in appearance, but at the end, it's not that different. Yeah, it's just more developer oriented. Yeah. This is why this is named the ROS Development Studio, because it's more oriented to developers. Yeah. Then here you can see a Jupyter notebook with the things we are going to discuss and talk today. And then here you have a menu with tools where you can open many things. You can open here a Gazebo window, a web shell. You can open an IDE. In fact, I'm going to open the IDE right now. Yeah. Graphical tools. Never mind. I'm going to explain this while we progress through the class of today and through the notebook. Yeah. Then basically today we are going to talk about ROS Basics concepts. Yeah. Let me make this bigger. So the class of today is going to be dedicated to explain ROS Basic concepts. Yeah. Basically, this is going to be how to structure and launch ROS programs, yeah, with packages and launch files. Then how to create basic ROS programs in Python in this case, and also basic ROS concepts such as nodes, ROS nodes, parameter server, environment variables, etc. Yeah. Then for being able to properly follow this notebook, this class, you need to have the requirements basics of Linux and Python basics, which for our lack you already have, because we did exactly this in the previous days. Yeah, on Monday and on Tuesday we were doing Linux and Python, so you are okay with these requirements. Yeah, so nothing else to add here. Then, as I've said, a project like this is basically a ROS project which is packaged in this project. Yeah, so here in this project you have everything. You have the ROS packages, you have the Gazebo simulations, and you have everything that will allow you to work with them. So you have an IDE in order to create and edit your programs. You have also access to RVs or visual tools like RQT, etc. You can launch Gazebo simulations. You can modify simulations. For instance, you can do almost anything. And the most interesting thing of this is that you can share this with your colleagues. Yeah, so that they can check what you are doing, or they can even collaborate with you, etc. Yeah. So if you want to learn more about ROSjects, you have some links here that you can have a look at them. But now let's set up the environment. So basically in this project I have a simulation of the Turtlebot 2 robot. And how I am going to start it? Well, in this case I'm going to start it with this simulations menu. Yeah, so I'm going to come here at the top bar in the simulations menu. You can see here. And I'm going to click here on the choose launch file button. Yeah. Then this is going to open a list of launch files. And I'm going to select the main.launch file from the Turtlebot Gazebo package. Yeah, so I repeat this. I'm going to come, it's explained here in the notebook. Yeah, so you can check here the steps as well. So I'm going to come here to the simulations menu. I'm going to click here on the choose launch file button, and this is going to open this pop-up where I am going to be able to select between many launch files. Yeah, and for this class, the one I want you to select is the one inside this Turtlebot Gazebo package, the one which is named main.launch. Yes? So let's select this one and click on the launch button. So this is going to automatically open here a Gazebo window. As you can see here, let me refresh this because it's kind of stuck. So this has automatically opened, as you can see here, a Gazebo window, which is going to load my Gazebo simulation. It should be like the one shown here in the image, yes? So this is still loading, you can see here, and mine has already loaded, yeah? So here I have my Gazebo simulation ready with the Turtlebot 2 robot with the wall, yes? And I'm going to set up this, I'm going to make this screen a little bit, this window a little bit bigger so that I can better visualize the simulation. Here, down here I have the IDE. And now I'm ready to start, yeah? So I have my environment set up and I'm ready to start. But before that, let me have a look at the comments and see how you guys are doing. Yeah? Okay, so let's continue. Alright, so let's keep going. Let's start. So basically, the first thing we are going to probably you are asking yourselves now is, what is ROS? Yeah, if you are totally new to ROS, the first question that when I talk with someone which is outside robotics and I explain him about what I do, about programming robots with ROS, etc., the first thing he asks usually it's, what is ROS? Okay, so this is a complex question which we are going to try to answer during today's class. Yes, but before that, let's talk about some things that actually are ROS, that make ROS what it is. Yeah. So the first thing I want to do is to move the robot with ROS, using ROS. Yes. And for this, we are going to use what it is known as launch files. Yeah. So the best way in order to move a robot is to execute a ROS program which does so. In this case, there are plenty of programs of ROS programs that are already made, which are supposed to be used in order to move or control a robot. Yeah, and the best way to start a ROS program is by using a launch file. Yeah, so that's what we are going to do right now. We are going to execute this command here. Yeah, we are going to come here to example 1.1 and we are going to copy here this command and we are going to paste it into a web shell. And in order to open a web shell, I need a web shell here. I'm going to come here to the tools menu and I'm going to click on the shell option. Yeah, and this is going to open a new shell for me. Yep. Then here I am able to paste the command and execute it. Yes, and this is going to generate an output similar to this one, and it's going to allow me to control the Turtlebot robot using the keys. Yes, here you have in the notebook specifications of what each key makes. For instance, the letter I is for moving the robot forward. Yeah, here you have everything. So now, if I put the focus into this web shell, I am able to control the robot. You can see there in the simulation how I am moving the robot around. Yeah, by clicking on the keyboard. You cannot see it, but I am actually here clicking on different keys of my keyboard in order to control the Turtlebot robot, to move it forward, turn, etc. Yeah. And how have I done this? Well, I have done this by launching a ROS program, which is supposed to do this. And I have launched this ROS program by executing a launch file. Yes? Then also let me remember to you, whenever you finish with the program, you can hit Control C. Yeah, you also have it here explained. Whenever you are done and want to close the program, you can hit Control plus C, and this is going to stop the running program. Yeah? Then, for doing this, we have executed this command, the ROS launch command, which is one of the most important and most used commands from ROS. Yeah? We have executed this command, ROS launch turtlebot teleop keyboard teleop. Yeah? So what does this mean? Well, the ROS launch command is used in order to start a launch file. Yeah? And what is the structure of this command? Well, it's like this. You have to first place the ROS launch keyword. Yeah? Then you have to specify the package name, the name of a ROS package, of the ROS package that contains your launch file. Yeah? And finally, you have to specify the name of the launch file. Yeah? So, in our case, here, we had ROS launch turtlebot teleop. So this is the name of the ROS package that contains this launch file, which is named keyboard_teleop.launch. Yeah? So, in fact, you can have a look here in the IDE, and you are going in the simulation workspace where you have all the simulation packages. You are going to be able to find here the turtlebot teleop package. Yeah, you have it here, and inside it you are going to be able to find here the keyboard teleop.launch. Yeah. However, let me just this is for more advanced users. Yeah, so that they can have a look here. Then, as I've said, in order to execute a launch file, you have to use the ROS launch command, follow it by the name of the ROS package that contains the launch file, and follow it by the name of the launch file. Yep. Then, what's a ROS package? That's the first question that comes from here. Okay, very nice, but what is a ROS package? Well, a ROS package is basically the way that ROS uses in order to organize its programs. Yeah? So, in order to have things organized and don't have all the programs there without any kind of order, ROS uses what it is known as a package. Yeah? So, inside the package, you will place all the programs that you want for something specific. Yeah? So, for instance, let's say that we want to create a series of programs that are going to allow me to move the robot. Yeah, then I would create a ROS package named, I don't know, you can name it whatever you want. You can name it, for instance, move robot package. Yeah, and then inside that packages you will put all the programs you create which are for moving the robot. Yeah, then for instance you could create another different ROS package which is named robot perception. Yeah, and then inside that package you would place all the programs which are related to perception, so for which are working with the cameras of the robot, getting the images of the cameras and processing them, etc. Yeah, so basically a ROS package is a place where you are going to put ROS programs. Yeah, and they are used in order to organize, to keep organized the ROS programs. Yes. Then each ROS package has an organization inside it. Yeah. Basically, the most important things inside a ROS package are the following we have here listed. Yeah. So inside a ROS package, you need to have a launch folder. Yes, and this launch folder is going to contain all the launch files. Yeah. Also, you are going to need to have an SRC folder, a source folder, let's say, yeah, which is going to contain the source files, the code files, either CPP, Python, whatever, yeah. And then you are going to have two special files which are automatically generated when you create a new ROS package, which are the semileaks.txt, which contains information for the compilation of the package, and the package XML, which contains some metadata, yeah, metadata about your package, yeah. So each package needs to have at least, well, it's not mandatory, but a standard ROS package will have this, yes. Then you are going to see exactly this right now. So in order to check this, we are going to go to a ROS package that we already have in our project. And how can we go to a ROS package? With ROS. So if you remember, in Monday we were talking about Linux, and the very first comment we showed was the CD command, yeah, the change directory command from Linux, which is the most basic Linux command. Well, in ROS we have the ROS CD command, yeah, and this command basically what does is to take us directly to a ROS package, yeah. So we can enter the ROS CD command followed by a package name, and then this is going to take us directly to where this ROS package is, yes? So we are going to do this right now with the Turtlebot Teleop package, the one we have used here in the first demonstration, yeah? In the first launch we executed here, ROS launch Turtlebot Teleop, keyboard Teleop. So we are going to come to this ROS package, and we are going to do so by using the ROS CD command. So let me click here, ROS CD Turtlebot Teleop, yeah, and this has taken me straight to where this package is, yes. So now I can execute the ls command in order to see what we have here, yeah. So basically here you can see a semilists.txt file, which is the file I told you is used. It contains information for the compilation of the package, yeah. You are going to work with this file probably tomorrow, yeah. It's they are complex files, so they require some more knowledge, but tomorrow we are going to probably work with them and modify them. So you can see here the semilists.txt file, the package XML, which contains the metadata. We have here a launch folder, and inside this launch folder we have launch files, yeah. You can see here the keyboard teleop.launch and the keyboard teleop cpp.launch, yeah. And also you can see here an src folder, yeah. And inside this folder, inside this src folder, you can see that we have a cpp script here, turtlebotjoy.cpp, and also turtlebot.py. So we have a Python script and a cpp script, yeah. So as I've said, we have the semilist, the package XML, and the launch folder, which contains the launch files, and the src folder, which contains the code files, yeah. And then also we have some other extra folders, for instance this param folder, which contains extra information, yeah? But the essential things that a ROS package needs to have are these ones, the one described, we have just described here, yeah? Alright, so let me do a small pause here and see how you are guys doing. I can see here a question, do all ROS packages need to be located in Catkin workspace or not? Yes. We are going to talk about this in a moment, Sujay. But yes, all ROS packages need to be inside a ROS workspace. What is Catkin? Well, we are going to talk about this also in a moment, so don't be impatient, because we are going to be talking and discussing all this in a moment, yeah? Catkin is a tool that allows you to compile ROS packages. All right, so let's go. Okay, so we have entered here the Turtlebot Teleop package. Okay, so we have discussed here about what is a package, and the other thing we need to discuss then now is what's a launch file. Okay, so basically a launch file is a file that ROS uses in order to start a ROS program, yeah? So it contains information in order to start a ROS program, yeah? And how do they work? How are these launch files written? Okay, so let's check it. Let's have a look at one of them. So we are going to have a look, in fact, at the one we have just executed. Yeah, this keyboard teleop.launch. We are going to see how this launch file is written. Yeah. So now we are inside the Teleop package. So I can come inside the launch folder, and here I can see my keyboard teleop.launch file. So I can do a cat, for instance, in order to see the contents of this file. And I can see it here, yeah? So basically you are going to get something similar to this. You have here the expected output in the notebook as well, yeah? And here I have in my shell, let me make this shell a little bit bigger, by the way. All right, yeah, so here I have the contents of this keyboard teleop.launch file. So what can we see here? First of all, we can see that it's opened and closed with a launch tag. Yeah. So all launch files are going to be started and finished with an opening launch tag like this one we have here, and a closing launch tag like the one we have here. Yes. Then inside these launch tags, we have a node tag. You can see it here opening and here closing. Yes? So we have first the launch tag, which indicates that this is a launch file, and then we have a node tag, which indicates that we are going to start a ROS node with this tag. Yeah? Then inside the node tag, this one here, we need to specify 4 different arguments, 4 different parameters. Yes? The first parameter is the package parameter. Yeah, here we have it with PKG. This is the package parameter, and in this first parameter we need to specify the name of the ROS package that contains our program. Yes? In this case, it's the Turtlebot Teleop ROS package, yeah? Then the second parameter is the type parameter. We have it here. In this type parameter, we need to specify the program we want to execute, the ROS program we want to execute. Yes? Then, in the third parameter, which is the name parameter, we need to specify the ROS node, the name that we want to give to this ROS node. Yeah, because this program is going to generate a ROS node. So here we specify the name we want to give to this ROS node. Yes? We are going to discuss later also about ROS nodes and what are they. And finally, we have the final parameter, which is the output parameter. Yeah, which basically this sets where do we want to print the output of our program. Yeah? In this case, it's set to screen, which indicates that we want to see the output of the program into our web shell. Yeah? So whatever our program does, we are going to see the output, as you can see here, in the web shell. Yeah? For instance, we could modify this and set it to print the output to a log file, for instance. Yes? So here we have also some param tags, but we are going to pass these ones for now. Yeah? They are not so important right now. So for now, we are going to forget about these ones. But you need to remember this. Every launch file has to start with an opening and a closing launch tag. And inside this launch tag, it will contain a node tag where we need to specify the following parameters: the package name, the name of the ROS package that contains your program, the name of your ROS program, of the file that contains your ROS program, the name that you want to give to the ROS node that your program will start, and finally, where do you want to print the output of your program. Yeah? So this is basically the basic structure of a launch file. All right. So let's keep going. Next thing, how to create a package. Okay, so we have already learned about launch files, about packages, about how a package is structured. Okay, but let's get to work. So let's create a ROS package. How to create a ROS package? First of all, we need to explain that every ROS package that you create needs to be, this is mandatory, needs to be inside a ROS workspace, which is known as the Cascade workspace. Commonly, it is known as the Cascade workspace. Yes? And this Cascade workspace is the location where you will place all your ROS packages. If you don't put your ROS packages inside this Cascade workspace, the system is not going to be able to detect these ROS packages. Yeah? And usually this Cascade workspace is named like this, Cascade_WS. Yeah? Here in the IDE you can see hours. If we open here we can open the Cascade workspace. In my IDE, yeah, and so every ROS package that you create today, tomorrow, or when you were with ROS has to be inside a Cascade workspace. Yes, this name is not mandatory to be like this. It can be the name can be different, but anyways, it is known as Cascade workspace. Yes, because it is generated using the Cascade tool. Yeah, but for instance, when I create it, I could name it, let's say Alberto workspace, for instance. Yeah, but it is known as the Cascade workspace. Then a Cascade workspace always contains 3 directories inside: the build, devel, and source folder. Then the build and devel folders contain compilation information, which we are not going to pay attention now. And inside the src folder is where we need to create our packages. Yes? So every new ROS package that you create has to be inside this src folder of the Cascade workspace. Yeah? So we are going to do this right now. Using a shell, we are going to come to our Cascade workspace here by doing cd Cascade workspace. Yeah? You have the commands here. cd Cascade workspace and cd src. Yeah? Now, if I execute a pwd command to see where I am, it should say that I am inside the home user Cascade workspace src. Yes? So this is the place where you are going to place all your ROS packages. As I've said, this is mandatory. If you don't put them inside here, ROS is not going to be able to find the packages you create. Yep. So this is super important, and this is answering a question I read some minutes ago in the chat as well. Yep. So yeah, let's create it. How can we create a new ROS package? Well, for that we have a specific ROS command, which is this one. It's Cascade create package. Yeah. So this package, it's well, this keyword is the one you are going to use every time you want to create a new ROS package. Yeah? So, in this case, we are going to do this. I'm going to just copy this command here and paste it to the shell. You can see the command is Cascade_create_package. Then we have my package, and then we have ROSPy here, which we are going to explain right now what this is. Yeah? So I'm going to hit the enter. And I can see here some feedback from the program, and at the end say successfully created files in my package. Yeah. So now if I come here to the IDE as well, inside the src folder, I can see how the my package folder has appeared. Yeah. And this is a basic, an empty ROS package that I have just created. Yeah. So, how does this command work? It's super simple. You need to specify the Cascade_create_package keyword, follow it by the name you want to give to your ROS package. In our case, we have named it my package. You can name it however you want. And finally, package dependencies. So, what other ROS packages I'm going to need to use for my ROS package? Yeah. So, in this case, we are importing ROSPy. Yes, ROSPy is a ROS package that contains tools that will allow us to program ROS with Python. Yes? That's why we are importing this ROSPy dependency, because we are going to need it in order to create Python programs for ROS. For instance, if we would like to work with C++ instead of Python, we would add instead of ROSPy dependency, we put the ROS CPP dependency, yes? Which is a different ROS package, yes? But in our case, we are going to add the ROSPy dependency because we want to work with Python. All right, so at this point, all of you should have this my package created inside your Catkin workspace. Yes, let me do a quick pause to see how this is going. You can see some comments here. Okay, I can see my colleagues are helping you guys here with some issues. So let me know if you, by the way, let me know if you are following me, guys. If you have any question, let me know here in the chat so that I can know that I can continue with you on the same page as I am right now. Because otherwise, I don't know if you are lost, if you are understanding me, if not, yeah?
Please, can you mention about the IDE, because this error, you did it very quickly,
yeah,
and then people is suffering with that.
All right, guys, let me do this. So I have been told that you guys, some of you are having problems with the IDE. Let me try to open this again. So, well, anyways, in case you have this loading and it's not working, click here in this reload button. Yeah, you have here at the top right corner of the window, you have here a reload button, and you can click it, and this is going to reload the IDE in case you there's any problem, and this should fix it, and you should be able to visualize your IDE properly. Yeah, so here at the top right corner of the window, of the IDE window, you have this reload button. Click it, and this should fix any issue you have with the IDE. Yeah. All right. Okay, very good question I can see here. I don't know if it's answered or not. No, I think no. Okay. What if we need to create both Python and CPP source file inside a ROS package? Do we need to give both ROSPy and ROS CPP as dependencies? Yes. This is a question from GBNT Matthew. Very good question. And yes, in that case, if you want to work with, if you are going to create CPP, C++ and Python packages, then you would add both dependencies, ROSPy and ROS CPP. In that case, you would do it like this. So you would add ROSPy space ROS CPP, yeah? And further on. So from this place, you can add as many as you want, just separated by spaces, yeah? Here you have another dependency, yet another dependency, yeah? But there's no problem. You can add as many dependencies as you want and as your package is going to need, yeah? That's a very good question, which shows me that you guys are following the class and what I am explaining. So that's great. Okay, so let's keep going. Let's keep going, guys. All right, so okay, so here I have yet another example with the ROSPack command. So how can I know here that my package has been created? In my case, I have checked it here in the IDE, and I can see that my package is here, yeah? But there is a command in ROS, which is ROSPack, which allows us to check and to do things with packages, yeah? So for instance, if we hit here a ROSPack list, I'm going to get a complete list of all the ROS packages that I have currently in my system. So let me execute this command. And here I can see many ROS packages. Yes, these are packages that most of them are installed, yeah, in the system. But you can see here all of these, each line is a different ROS package that I have installed in my system. Yes? So, you can see here the ROS launch command, for instance. You can see here the ROS CPP command. Yeah? You would find here as well the ROS Py command, etc. But there are too many, so let's do one thing. I'm going to add a grep here. I'm going to execute a grep program in order to filter them. And I'm going to filter this in order to try to find the one which is named my package, which is the one that I have just created. Yeah? If I execute this command, I can see here my package, and it tells the name of the package and the location of this package. Yes? So in this case here, in the big list, you could see many which are installed in the OPT ROS Kinetic Share folder. In my case, I can see here my package which is in Home User, Catkin Workspace, SRC. Yes? So this tells me that ROS is able to detect my package, the one that I have just created, so that the package has been correctly created. Yep. And also I can do a ROS CD to go to my package. And if I execute the ROS CD command to my package, this is going to take me directly to the location where my package is. Yeah, I have it right here. Yep. All right, excellent. So we have created our first ROS package. Great. So now that we have our first ROS package, it's time to create our first ROS program. Yes? So that's what we are going to do right now. So, as you can see, by default, when you created your program, your package, your ROS package, we had a semiglist.txt file automatically created, also a package XML file automatically created, an SRC folder automatically created. Yeah? So, before in this live class, we said that every ROS program that we create needs to be inside the source folder. Yeah. In this case, we have our source folder here automatically created. So, any ROS program we want to create for this package, we are going to place it inside the SRC folder, inside the source folder. Yeah. So for this, we can do it from the shell. For instance, we can do it with the touch command and create our file. We can do it from the IDE. As well here, right click and new file. Yeah, so you can do it however you want. Yeah, the method that you prefer, that suits you the most, you can do it that way. And we are going to name this file simple.py. So I'm going to do it through the IDE right now. So I'm going to come here to the SRC folder, new file, and I'm going to name it simple.py. This is going to create a file which is going to be empty by now. Yeah? And then inside this file, we are going to copy and paste the code we have right here. Yep. So I'm going to come here, copy all this code and paste it into my file. Yes? So now I have my package with the SRC folder, and inside this SRC folder, a simple.py script with this code. Yeah, this is where you should be right now. All right, so let's keep going. Yeah, so what do we have missing here? Because when we explained the structure of a package, the basic structure of a package, we mentioned, let me go back here real quick to that section. So we mentioned that every ROS package has the following basic structure. We have the package XML file, semiglist txt, SRC folder, and launch folder. So in our package, we already have the package XML, we already have the semiglist txt, we already have the source folder, but we do not have this launch folder. So what should we do right now? Well, we are going to create this launch folder, yeah, which will allow us to place our launch files there. Yes, so that's what I'm going to do right now. So I'm going to come here You can also do it from the IDE if you want. Right click here, new folder. Yeah, in this case, I'm going to do it from the web shell to keep changing methods. So I'm going to come to my package here, and I'm going to do an mkdir command, which we learned also along this week. Mkdir, and I'm going to name it launch. And this is going to generate a new folder. You can see it here and also in the IDE. This has created a new folder named launch. Yes? So, right now, what I want you to do is to create the contents, the launch file inside this folder. Yes? So you can create, the launch file right now. Let's assign the name. We are going to name it my_package_launch_file.launch. You have the name here. So I'm going to create it here inside the launch folder. I'm going to create my launch file. There we go. Very important, the extension. Remember that every launch file has to have the .launch extension. Yes? This is what tells the system that this is a launch file. So super important. And then I want you to fill this launch file by yourselves. I'm going to give you, I don't know, maybe 5 minutes until 20. Yes? So I'm going to give you 5 minutes so that you can, by yourselves, fill the contents of this launch file. You can have a look at this one to take an example. You can have a look at the one we had here in the notebook. Yes? You can copy paste this one if you want. You can remove the params here, the param tags and the remaps, and leave only the node tag, like so. There we go. Yes? And with this structure, with the launch tag and the node tag, do the proper modifications so that you are able to launch your program, the program you have just created. Yeah? This simple.py program. So I'm going to give you 5 minutes to see, to let you do it by yourselves, and let's see if you achieve it or not. Meanwhile, I'm going to go back to the chat and see how things are going. All right. Okay, I can see a comment here from Nuria Pujol. Can you share ROS link again? Yeah, let me do it real quick. 1 second. I'm going to pass it to you right now, Nuria. Let me try to find it. Okay, here I have it. Here I have just put the link in the chat, Nuria. All right, I can see also Gada Salim that is saying IDE is not loading. Okay, let me remember this. If your IDE is not loading, click here on the reload button. Yeah. So if your IDE is not working, click here on the reload button. This is going to reload the IDE and it's going to fix any issue you have with the IDE. Yes? Reload button at the top right corner of the IDE window. All right, so okay, you still have 2 minutes, a couple of minutes in order to complete this first launch file, and I am going to do it myself right now when these 2 minutes pass, but I want you to try to give you some time so that you can try to figure out by yourselves. Very good question. I can see here from Jibin Timothy. Okay, Jibin, I can see that you are paying attention to what I am saying. He's asking, can we add more dependencies to the ROS package even after creation of the package? Or is it possible to do only at the time of ROS package creation? Okay, this is a great question. And the answer is that yes, you can add dependencies even after you have created the package. Yes? In fact, we are going to do this tomorrow. In the class of tomorrow, we are going to have to add a package dependency after package creation. But in order to give you a taste of this, I'm going to just let you know, explain you, that for that you need to modify the package XML file. Yes? So here, you can open the package XML file and you're going to see that you have here listed the dependencies of your package. Yes? Here, right here, you can see that in my case, we have build dependencies and execution dependencies with their ROS package. You can see them here. This has been automatically added here because I have specified them when I was creating the package. Yes? Also the catkin, which is always added, this one. This is always added by default. But then here we have the ROS dependencies. So you could come here, for instance, and just copy and paste this and add here the ROS CPP dependencies, yes? And this would make the trick. Well, not actually, because you would have to also add it here to the CMake lists. Here, yes? But don't worry, I'm going to explain this tomorrow, yes? But the answer to your question is yes. You can add dependencies to your package even after creation. Very good question. I'm really liking your questions here. All right. Fabio Lisurici says, why do we need a launch file? Because it's the best way to start a ROS program. Yes, maybe now you don't see a huge use of this, but you have to think that we are starting to learn ROS step by step. So now our launch file is very small. You can see it here. Yes. It's just launching one program, but usually for robots, for a humanoid robot, for instance, imagine how many ROS programs you are going to need in order to make a humanoid robot work. You're going to need hundreds and hundreds of programs being running at the same time and launched at the same time. Yes? So the best way to organize this, how to launch all the different programs of your robot, etc., is with launch files. Yes, because inside the launch file you can start many ROS programs at the same time. Here we are just starting one, but we could add another node here, down here, and this will start a different ROS program after this one. Yes, and etc, etc, etc. Yes, so launch files are the best way to organize how you want to start your ROS programs for your robot, for instance, when you have to launch many ROS programs at the same time. Yes? Alright, so I'm getting interesting questions. I'm liking this. Kiran So says, why we need to create package only under source files of Hacking Workspace? Any particular reason? Yes, because okay, I'm going to explain this a bit later. Yes, because for this I will need to explain something about an environment variable, which I'm going to explain later in this notebook. Yeah. So later I'm going to come back to this. I'm not forgetting out this question, Kiran. I'm going to explain it later. Okay. So let's go on. I will read more questions later, but we need to keep moving. All right. So I have my launch file here, and I have my program here. So for my launch file to start my ROS program, the one I have created, I need to modify some things here. First, the package name, it's not Turtlebot Teleop. In this case, the package name is my package. Yes, this is the name that my package, that the package I have created has, my package. Then, the name of the program is not Turtlebot Teleop key.py. It's simple.py. simple.py. So I need to modify this as well. Yes, this is the name of my program, simple.py. Then the name of the node, I can check it here in my code. Yes, in this case here, I'm using OB1, so I'm going to get the same name as here. I'm going to explain this code right now, yes? Don't worry. So, in this case, I'm going to get the node name from this line, and I'm going to paste it here, so the name of the ROS node is going to be OB1. And finally, the output is going to be to screen. Yes? Then now, I'm going to launch my program. So, let's launch it. ROS launch. My package and my package launch file dot launch. I'm going to run this, and I am getting an error here, which is great, by the way. So here, as you can see, I am getting this error. Cannot launch node of type my package simple.py. Can locate node in package my package. Yeah. So many of you, if you have tried this, you are going to get this error. How do you solve it? Well, if you paid attention at Monday's class, yes, you are going to know how to solve this. Basically, what this error means is that my Python script, this simple.py I have here, doesn't have execution permissions. Yes? Do you remember this from Monday? Yeah? So in order to solve this error, you need to give execution permissions to this Python script with the command chmod +x simple.py. Yes, this. So with this command, which you should have somewhere here in the notebook as well, or maybe not, I don't know. However, this command, if you were paying attention on Monday's class, you are going to know this. Yes, you need to give permissions to the Python script, to this simple.py file. Yes, you can do so with this command, chmod +x and the name of your file, which is simple.py. Yes, so now if I run again my program, let's do it, let me do it. This is going to, the error is going to disappear and my program is going to work. Yes, in this case I'm going to see here this line, this string, which says, help me Obi-Wan Kenobi, you're my only hope. You have it here in the output of the program, yeah? So, what is this program doing? Let's explain it right now. What is this ROS program that we have created doing? Let me close this. And the launch file, here we have it. Okay, so this is a super simple ROS program. Just 4 lines, so let's go line by line. First line, this is telling my system that this script needs to be executed as a Python script. Yes? So that basically it's telling the system that this program is a Python program. So it needs to be executed by Python. Yes? We are setting here the Python environment. Yes? Then, first line we have is an import. You remember imports from yesterday's class, from the Python live class we did? You remember import? So here we have an import. We are importing ROSPy. So basically we're importing this ROSPy module, which I explained before that this module allows us to program with Python for ROS. Yes? Then, next thing I do, I am starting a ROS node. Always I create a ROS program, I need to, first thing is to initiate my ROS node. Yes? I need to initiate a ROS node. This is the very first thing you need to do when creating a ROS program. So here, I am calling the function init node from the ROSPy module. You can see here from the ROSPy module, I am calling the function init node, which is going to initialize a new ROS node, and I'm giving it the name of Obi-Wan. Yes? And then, once my ROS node is running, I am doing a simple print here. Yes? And the print says, help me Obi-Wan Kenobi, you're my only hope. Yeah? So that's why when I executed my program here, I was able to see this string printed in my shell. Help me Obi-Wan Kenobi, you're my only hope. Yes? So, let me do a very quick stop here to check the to check the chat. Okay, I can see here Engineering Nation. Engineering Nation is doing a very good question as well. Since it doesn't say Python 3, does that mean that it's running Python 2 by default? Yes. ROS currently, ROS Kinetic and also ROS Melodic. So ROS currently only supports Python 2 officially. Yes. There are some ROS packages that work with Python 3. But there are some packages, ROS packages, that don't work with Python 3. So by default, ROS only supports Python 2. Yes? For instance, the new version in the new ROS 2 version that is has come out now, ROS 2 supports Python 3, yes? But ROS 1 doesn't support Python 3. Doesn't fully support Python 3. Alright, so let's keep going, let's keep moving. So, with all these explanations I have just done, the very first question that should come to your mind is, what is a ROS node? Yeah? Because we are talking here about ROS node, initiating a ROS node, but what is a ROS node? Well, a ROS node basically is a process where your ROS program is going to run. Yeah, let's say like this. It's like a thread where your ROS program is going to be executed, is going to be run there. Yes? Then, usually you can say that a ROS node, it's basically a ROS program. Yes? Because when you create a ROS program, you are going to have to initiate a ROS node. So, each ROS node is going to be associated to a ROS program at the end. So, in summary, you can say that a ROS node is a ROS program. It's the process that contains a ROS program. Yes? Then we have this command, ROS node list, which is going to allow us to see a list of all the ROS nodes that are currently running in the system. So if I come here and execute this ROS node list, I'm going to get a list with different ROS nodes that currently are running. Yeah, most of them are related to the Gazebo simulation. You can see here Gazebo, Robotics Publisher, ROS out, which is for the ROS logging system. Yeah. So here we can see the list of ROS nodes that are currently running in my system. So you might be asking yourselves, okay, but in my program, I was starting a ROS node here, which was called OB1. Why I cannot see it here? Because you cannot see the OB1 ROS node here. Why is this happening? And that is a very good question. So if you are starting here a ROS node, why you cannot see it here when you execute the ROS node list? Alright, so the answer is because your program here, it's ending. Yes? So you are initiating here a ROS node, call it OB1, then you print here a string, and then right after the program ends. So when the program ends, the ROS node dies as well. Yes? So it is only alive for some milliseconds, let's say, for the time that this print is being executed. Yes? After this, the program ends and the ROS node dies. That's why you are not able to visualize it here. So how can we change this? Very easily. So what we can do is to add here to our Python script some kind of loop which prevents the program from ending until I tell the program to end. Yes? So also, if you were in yesterday's class where we were talking about Python, we explained about loops in Python, how to create loops. In this case, we are going to use a while loop. Yes? So we are going to need to add some things here. So first of all, you have here you're going to come here and you're going to grab this code and paste it. Yes? So let me Control C this simple loop.py. I'm going to put it here. Oh, in fact, I'm going to create a new program. So I'm going to create here a new one named simple simple underscore loop dot py. And I'm going to paste this. Yes? So, what do I have here? Here, the first line is exactly the same as the other one. Here, exactly the same. We import ROSPy. Exactly the same. We initiate a ROS node named obi1. Then here, this is new. What we are doing here? Here, we are declaring a new variable, and we are assigning here a rate to this variable. In this case, the rate is of 2 Hz. Yes? We are creating a rate object of 2 Hz, which is going to help us control the flow of our loop. Yes? Then here we are initiating our loop, our while loop in this case. Then here I'm saying while not ROSPy is shut down. So this ROSPy is shut down means it's basically a shutdown signal sent to our program. Like, for instance, a Control-C, yeah? So when we hit Control-C on a running program, we are basically sending a shutdown, a kill signal to it, yes? So this while is saying, while not ROSPy is shut down, so while I don't receive any shutdown request, this is going to keep executing. So the print is going to keep executing. Yes, this help me Oyankonebi, you're my only hope. And here I have an sleep, as you can see, for from the rate variable that I have declared here, which remember it was a rate of 2 Hz. Then basically here what I am making is to make sure that my loop maintains a frequency of 2 Hz. Yes, it doesn't go faster or slower. It just maintains, keeps this frequency of 2 Hz. Yes? Alright, so let's execute this new program. Well, first of all, let's we have to make sure that this new file has execution permissions. So this is the first thing I need to do here. All right. Here, let me give execution permissions to this new file I have created. And then also I'm going to modify my launch file so that instead of starting the simple.py file, is going to start the simple underscore loop.py, which is the new program I have just created. Yes? Then right now I'm going to, actually not here, but in the other shell I had there. Oh no, I have it here. Okay. So here I'm going to do a ROS launch, my package, and my package launch file.launch. Yes, so now I am going to execute my new program, the one that I have just created. And let's see what happens, let's see what we get. Alright, so I'm getting the... Okay, yeah, so here I have an error, a misspell error, a misspelling error, yeah. I have put, instead of loop with 2 O's, it's loop with 2 P's. Yes, so this is an error here in my launch file, as you can see. Yeah, so here I need to remove 1 P and add 1 O. There we go. So let's run it again. And now we are going to see this string being printed until someone controls C the program, until someone stops this program. For instance, by pressing Ctrl C. Yes, now I have finished the program, so the flow stops. But why I wanted to do this? I wanted to do this to check to see if I am able to see, to visualize this ROS node that I am generating here, that I am initiating here in my program. So let's start one more time the program and keep it running. And I am going to open another shell while my program is running here in this one. And from this other shell, I'm going to execute the ROS node list program. And now here I am able, as you can see in the list, I have this obi1 node. Yes, you can see it here because my program is running still here. So my node is still visible. Yes? So now, for instance, if I stop my program from running here and I execute again the ROS node list, I don't have the OB1 node anymore. Yes, because it has died. Because I have killed my program. Yes? Excellent. So far so good. We are almost there. More commands from the related to nodes. So let me run one more time the program so that I have the node. So we have seen the ROS node list in order to see the list of nodes running, and we have also the ROS node info. Then here we have to specify a specific node. In this case we are going to put OB1, and this ROS node info gives us information about this specific node, yeah, about the node that you specify in the command. In this case it's ROS node info OB1, yeah. So here I can see some information about this node: publication, subscription, services, etc. Tomorrow we are going to be talking about publishers and subscribers. So tomorrow you are going to understand better this, and it's going to make more sense to you, yeah? But for now, just keep in mind that the ROS node info command will give you information about a specific node. Yep. All right, so far so good. So let me do a very quick stop here. We are almost done. I think we are going to be able to make it in time today. So let me have a quick look at the chat to see how things are going.
Can you answer this question about that says Kobe Hathon, that says it is only printing one time for me.
Okay, so Kobe, if it's only printing one time for you, this is because you are executing this program, the simple.py program. You don't have any while in your program. Yes? So if you want to get the same output as I am having here, where my program keeps running until I manually stop it, yes? Let me stop it here. You need to use this code, yes? The one which contains a loop here. The while not ROSPy is shut down. Yeah, you have the code. You can get the code here from the notebook. Yes, here, simple loop.py. Here you have the code for this new program. Yes? So you can copy paste it from here. All right, so quick look here. Good. Well. Okay, Kobe says, I understood why. I paused the simulation. Yeah, that's a problem as well. So here I have the simulation running, yes, but I could pause it if I wanted to, yes, but don't pause it, just leave it running. Okay, yeah. All right, yes, Fernando Lima, the video is going to be available after we finish. All right, so let's keep going. Let's keep moving. Let's try to finish this. All right, so next thing I want to introduce is the compilation concept. Yeah, how do we compile a package? So in ROS, we are going to use the catkin_make command in order to compile a package. Yes, then in the same way I told you that when you create a package, it is mandatory that this package is placed inside the src folder of your catkin workspace. Yes? This command, the catkin_make command, it is mandatory that it has to be executed in the catkin workspace folder. Yes? At this level. Here, let me do a pwd. So here, you need to execute this command in the catkin workspace folder. Yes? If you try to execute this command in order to you confirm me, Ricardo, that everything is working fine?
In which sense?
The stream, you can see everything properly?
Yes.
Okay, I got a strange message here. OBS disconnected.
here. Still, maybe it's the delay, because of the delay, but I can see.
Okay, I'm going to keep talking, and if there's any problem, you let me know.
Can you switch to your camera?
Yeah, let me switch to my camera.
And then see if we can see you. But it takes a few seconds, at least like 20 seconds or 30. Yes, I can see you, no problem.
Alright, so I'm going to keep going. Everything seems to be working properly. So I'm going to go back to my PC screen and let's go. Let's try to finish this. There are just a couple of things to explain, so see you in a moment. Alright, so I'm back here at my project. Then, if we want to compile a package, we need to execute this catkin make command. And this catkin make command, it is mandatory that it is executed in this catkin workspace folder. Yes? For instance, if I try to execute it inside the src folder, let me try to do it, and let's see what I get. I get an error. Yes, you can see an error here. So, if I go back to the catkin workspace folder and I execute it here, catkin underscore make, now it works. Yeah? So it is mandatory to execute it here. Keep this in mind. Yes? Then for this case, you are going to see that I'm not going to compile nothing because we are working with a very simple ROS package, which contains a Python script. Yes, and Python, as you may already know, doesn't need to be compiled. Yes? So, in fact, here I'm compiling nothing. Yes? But it's important that you know how to compile a package because tomorrow and on Friday, you are going to need to do it. Yes? So that's why I'm explaining it now. And in general, you are going to need to compile packages. Yes? So that's why I wanted to explain. Then, this catkin make command is going to compile all the packages inside the src folder. In this case, we only have one, which is my package. But imagine that we have hundreds of packages inside our workspace. But I have just done modifications to one package and I just want to compile one package. I don't want to compile hundreds of packages because it's going to take hours, yes? And I just want to compile one. So, in that case, we can use the following suffix. This one, only package with deps. Yes, so we can specify here catkin underscore make / only package with dependencies, and then I specify here the name of the package I want to compile. In this case, my package. Yes? So with this suffix here, the only package with dependencies, I can specify just the packages I want to compile. Yes? So the catkin make command is going to compile all the packages inside your workspace, and this way you can specify if you want to compile just one or two or three. Yes? It doesn't matter, but you can specify which packages you want to compile. Yep. Then, finally, when compiling, super important as well, you are going to need to do this tomorrow as well. After compiling, you need to source your workspace. How do you do this? With this command, source devel setup.bash. Yes? Keep in mind, remember very well this command because you are going to, if you want to become a ROS developer and you are going to develop ROS programs, you are going to be executing this command many times each day in your life. Yeah, so remember it very well. Source devel /setup.bash. Yes, so this command basically is going to source your workspace in order to get all the last changes after compiling. Yes? Alright. Then, parameter server, very quickly, I'm going to go very quickly on this one, on the parameter server. Here we have it. So the parameter server, basically, it's, let's say that it's a dictionary that ROS uses in order to store parameters. Yes? So, for instance, you can execute here the ROS param list command, and you are going to get a whole list of parameters here. And you can set parameters, get parameters for your programs, etc. Yes? But basically, keep in mind that it's a place, the parameter server, it's a place provided by ROS where you can set parameters so that from your ROS programs you can get them in order to use them. Yes, this is usually used for configurations, for configurations of robot sensors, etc. Yes, or also for configurations of your own programs. Yes. Anyways, I think I'm going to skip a little bit these exercises because I don't think they are important right now. We are not going to use them right now. So if you are interested in this, have a look at the parameter server and complete this example here by yourself. Yes, but I want to finish talking about ROS core and also the environment variables, which are the two last things. And we have 10 minutes, so I want to explain these ones better than the parameter server. So ROS core, what is ROS core? ROS core, let's say that it's the ROS God, let's say. So the ROS core, it's the main process that will contain all the ROS programs and all the ROS nodes that you are going to launch. Yes, so it's the main father or mother, let's say, ROS process from which all the rest of ROS processes and programs are going to come. Yes, so without a ROS core process running, you are not going to be able to work with ROS. It's not going to be possible. Yes, I'm going to show an example of this right now. So in order to start a ROS core, you need to do it with the ROS core command. Yeah, but what happens? You probably are asking right now, okay, but we haven't executed this command and we are working with ROS here. We are launching programs, checking nodes. Yes, you're right. Why? Because when you started this simulation, the ROS core was automatically started for you. Yes, so there is actually a ROS core running in the background. You started it when you launched the simulation. Yeah? For instance, if I close my simulation, now, yes, I have closed my simulation, and I'm going to try to execute a ROS node list command. What happens? I get an error. It says, error, unable to communicate with master. What does this mean? Well, this means that there is no master. There is no ROS core running. Yes? So, now, if I come here and launch a ROS core, I'm going to do it here, another shell, ROS core. I have started here my ROS core, and now I can come here, execute a ROS node list topic, and now I can see here, I don't get the error anymore, and I get my node, which is ROS out. Actually, since I don't have any simulation and nothing running, I just have this ROS out node running. Yes? But you can see here the importance of ROS core. So if you don't have a ROS core running, you are not going to be able to work with ROS. Yes? All right, then let me start one more time the simulation in order to end this properly. There we go. It's going to start here in the background. All right, here I have my simulation starting. Then final thing. Environment variables, yes? So this is nothing else than a set of Linux environment variables, yes? If you are used to work with Linux, you probably know about environment variables, yes? They are used in Linux, and ROS also uses these environment variables in order to get information usually about ROS connection settings, yes? About information that is required by ROS in order to work properly. Yes? The way to have a look at the environment variables related to ROS is by executing this command. You have it here, export pipe grep ROS. I'm going to copy it and paste it here into my shell. And here I'm going to see all the environment variables which are related to ROS. I can see here ROS package directories, ROS distro. For instance, this ROS distro indicates that the ROS distribution we are working on, which is Kinetic in this case. Yes, ROS hostname, etc. But the two most important ones are the ones that you are going to use the most on your ROS career, let's say, are these two, ROS master URI and ROS package path. Yes, these are the two most important environment variables that you need to memorize, that you need to be aware of. Yes, then the ROS master URI variable, we can see it right here, ROS master URI. In this case, it's pointing to HTTP master 1131. What this is? This is the name of this computer, of the computer where you are executing your ROS project. Yes. So basically, the ROS master URI indicates the URL where the ROS core is being executed. Yes. So as I've said before, here you are running a ROS core, which is started automatically by the simulation. And you are working here in a machine which it's in the cloud, yes. But basically, this machine, its name, it's this, yes. Its URL, better, it's this, yeah. HTTP master, and this is the port, yes. So basically, the ROS master URI tells you the URL where ROS is running, yes. And why this is important? Well, this is important, for instance, for connecting to a robot, yes? So you can, let's imagine that we have a robot which has ROS installed in the robot's computer with programs, yes? And you have ROS running there in a computer in your robot. Then, from your computer, from another computer, you could set the ROS master URI, modify it, and set it to the same URL that you have in the ROS system running in your robot. Yes? And then, if you set the same ROS master URI than the one you have in your robot, you are going to be able to communicate with the ROS system, with the ROS topics and nodes running in your robot from your computer. Yes? So this is the power of the ROS master URI and the utility. Yes? Then, finally, the ROS package path. What does this? This is going to allow me to answer a question I passed some minutes ago, which I said I was going to answer later, and this is the moment. So the ROS package path, you can see it here. This you can see it indicates a series of directories. Yeah, we can see here our home user calculating workspace SRC, another home user simulation workspace SRC. We can see some workspaces. Yes, so basically, this variable, this environment variable, contains all the workspaces where ROS is going to look for packages. Yes? So that's why it is so important that you put all your ROS packages, in this case, inside the Catkin workspace SRC folder, because ROS is going to come to these paths, to these workspaces, to look for his programs. Yes, to look for his packages. So if you create your ROS package in a path which is not contained here in the ROS package path, ROS is not going to be able to detect that package. Yes? Alright, so we are basically done here. So we can now answer the... Wait, we have one question here.
Yes, it's about the exam of the prerequisites part.
Yes.
And then so people is complaining that they haven't received any results.
Yeah.
So they should have received the results in the moment. So some
Yeah.
minutes later.
Yes. Yes, let me just close this and I'm going to
Okay.
with this, okay? So finally I wanted to answer here the $1 million question. Yeah. So now, what is ROS? Well, basically ROS is this. Basically ROS is the framework that allows us to work with all these tools that we have seen here. Yes, it allows us to have a place where we can execute nodes, and each node is going to be a program which can intercommunicate between them. Yes, all of them running under a ROS core. Yes, so basically ROS is the framework that will allows us to create programs for robots and communicate between them. Yes, and much more, of course. So you need to understand as well what topics are, which is exactly what we are going to explain tomorrow. Yes. So how can a node a ROS node, so a ROS program communicate with another ROS program with a topic, yes? So this is what we are going to learn tomorrow. And this is the main tool, topics are the main tool that are going to allow us to create any ROS program, yes? Super important. So tomorrow stay tuned because we are going to talk about ROS topics and also ROS messages, yes? So just a couple of things to finish this. Here you can have you have some ways of supporting us, etc. Here you can see, for instance, how to get the cops. I saw some messages also in the chat of people asking us for these cops, how you can get them. Well, you can see it here. So yeah, that's all for the class of today in terms of explaining. So now let me come out here. I'm going to go back here. So Ricardo was commenting me that some of you had problems with the results. Well, let me have a look at this. Well, in fact, I'm not going to be able to enter. I don't think I'm going to be able to enter into a course. Let me try it into an exam to show you. But I think it's going to ask me for confirmation. Yeah, so I cannot enter here. All right, so let me try to explain it in a different way. So in theory, in your exam, when you enter the exam, you are going to have a notebook like this one here with the simulation, the ID and everything set up there as we saw in the previous day in the academy, yes? Then here at the left side, at the top left side, you are going to have a button, a green button, which is going to allow you to auto-correct the exam, yes? Then by pressing that button, you are going to get automatically the mark. So the system is going to automatically correct the your exam, your test. Is going to get the packages you have created, test them, and it's going to provide to you a mark, yes, automatically. And you are going to find that explained in the notebook at the last part of the notebook. You have that explained, but basically it's a button, as I'm saying, that it's appearing here somewhere in the top left corner of your screen. You're going to have a button, a green button, which is going to allow you to auto-correct your exams. And you're going to get a mark there. Yes? Interesting. Okay. Raul is asking, tomorrow is just for subscribers. No. Raul, tomorrow we are going to talk about ROS publishers, ROS subscribers, and ROS messages, and ROS topics, of course. Yes, so tomorrow you need to come with an extra cup of coffee because it's going to be a strong day. Yeah? Richard is asking, is there another exam for this ROS part of the course? Not an exam, but we are going to do a project on Friday. Yes, so with everything you learn here, we are going to be doing a project on Friday, which I'm going to be providing more details to you. By the way, let me switch the camera because you are watching here. Let me show you my pretty face. One moment, I'm going to show one moment again here the schedule. So today we've done the ROS Basic concepts, which we have covered 100%, just in time, which is excellent. Then tomorrow we are going to talk about ROS topics and messages. And then on Friday, we are going to finish this, probably with some questions you have or some things we don't have to do, we don't have time to do tomorrow. We are going to finish it on Friday, and we are going to start doing the ROS Robotic Challenge, which I'm going to explain to you on Friday. Yes? Where you are going to have the chance to apply everything you've learned during this week in this ROS Robotic Challenge. Yep, I will give more details about this on Friday.
So team is indicating that.
Yeah, I can read today's course. It's this one.
Yeah.
Today's course started slow and finished fast. If you could balance that a bit, please. Yeah, you are right, team. We started slow because we had many problems at the beginning of the class. I was seeing many users having problems in order to access the platform. So I was trying to make time so that everybody gets time to enter and to be on the same page. So that's why I went a little bit slower. And well, while progressing, I was starting to get a good rhythm. Yeah, but tomorrow hopefully we are going to have no problems to start, so that we are going to be able to keep a good pace all along the class. Yeah. Alex Charters, very good question. What happens if the code takes longer to execute than the specified rate? Is the rate guaranteed, or is it only followed as well as possible? It is only followed as well as possible, so it is not guaranteed, Alex, in that case. Very good question. It was great. Raul says, see you tomorrow. Thank you very much. I never could. Some people with problems here as well. Link for the exam, you have it here. Let me show it one more time. Okay, so in order to access the exam, you can come here. If you want to do the Brexit exam, you can come, where it is. Sorry. You can come here to RIA, sorry, Robotics Ignite Academy. Here I am. To the featured paths, you will find it here at the top of the page. Yes, in the Academy, in the courses section. Here you have the featured paths. Then you can enter here the Code Foundation for ROS. And here, at the end, you are going to see here the Brexit exam. And you can click Start Exam in order to do it. Yes, it will ask to use some information like a picture, etc., to validate that it's you that is doing the exam. But it's here where you can do it. Yeah. Let me have a last look here. Okay, some people is asking here the Discord link again. I'm going to give it to you one more time. Give me 1 second. Let me find it here. And I'm going to, also for the people who missed it, I'm going to share it again here. Okay, let me come. 1 second, where I have it here. Okay, so I'm going to share it right now in the chat one more time, the Discord link. There you have it. Yeah, so remember, all of you, if you want to keep chatting between you, sharing your experience on these live classes, sharing your ROS projects, talking about ROS, talking about robotics, you can do it here in the Discord channel, and you can also talk with us. We are also there. We are going to keep checking what you are saying there and that you are behaving correctly. No, it's just joking. All right, so yeah, that's basically everything for today's live class. I hope you enjoy it and you have learned something new. Sorry for the problems. We are going to try to solve these connection problems we had for tomorrow. We are going to do our best in order to provide you a better experience tomorrow. So please keep trusting us. We are going to make it. And tomorrow it's a super important day. I would say that it's the most important day of the week, because this is the day where we are going to explain the core of ROS, which is topics, which is probably the most important part in ROS topics. So please don't miss tomorrow's class. And yeah, as I've said every day, keep staying safe, keep staying home. We are going to keep providing content to you so that you don't have to go outside. You can be having fun and learning from your computers in home without having to go out. And yeah, that's all for today. So I will see you tomorrow and keep pushing your ROS learning. Well, do you want to add something, Ricardo? No?
It's your class.
Okay, then we are going to end it here. Yeah. So goodbye. See you tomorrow. Bye.